Alrighty guys, today we are hopping into a new slideshow and a new set of notes talking about terrestrial biomes. If you are following along with your student notes, either printed or on Schoology or your computer or whatever, we're going to be doing pages 1 through 18 of our notes today, I believe, talking all about biomes. I know this can be kind of boring because this is something that you've probably learned about in a lot of your classes, your science classes throughout the past, 10 or 11 years. But hopefully it's still something you learned something new today, maybe. Also, this is a PowerPoint, not a Google Slides that I've got pulled up right now because it said the file was too big to open with Google Slides. So if you notice any strange formatting or transitions that are a little bit off in this presentation, that would be why, because I had to open it with PowerPoint instead of Google Slides. So to get right started, you know what I mean. To get started, what's a biome? This might be a little bit more of an in-depth discussion of what a biome is than what you might have been used to from maybe like 7th grade life science or what other classes you've learned about this in the past. But obviously, it's a large region of the biosphere, and it is characterized by a type of climate and certain types of plants and animals. I think that's going to be something that a lot of people forget when it comes to that definition, is that not only is it just a large geographical region, normally, it's also characterized by very specific things, like a specific climate, certain plants, certain animals. It also contains characteristic communities of plants and animals that result from and are adapted to its climate. So the plants and animals that are in this biome or in any biome are specifically adapted to or resulting from that unique climate that biome has. So talking about resource distribution, I think we talked a little bit about this previously, but the global distribution of non-mineral, that's a lot of words here, non-mineral terrestrial natural resources. So it's not geologic, it's not minerals or rocks, it's terrestrial, so it's not in water, it's on land, and they're natural resources, such as water and trees for lumber. It can change, and that can be due to things like climate, geography, latitude and altitude, nutrient availability, and soil. It's pretty dynamic the way that the biomes are distributed. The worldwide distribution of biomes has changed in the past and may again shift as a result of global climate changes. Changing temperatures and precipitation may cause changes in vegetation, thus changing the biome. So, as we know, hopefully right now the world is changing quickly and in a scary way. Temperatures are rising, rainfall patterns are being disrupted, wind patterns are being disrupted. So as those things change, it can cause changes to happen in vegetation and plant life. And so once that plant life changes, remember that plant life is one of the big determining factors for what biome is which. And so if that changes, then we could easily make the connection and say that human activity and climate change caused by humans could be leading to biome redistribution as well. So we have already begun talking about this in both the slideshow project y'all did yesterday, as well as the chart that y'all did on Monday. But we are going to talk about the tundra, the boreal forest, temperate deciduous forest, temperate rainforest, grassland, desert, and shrubland. Go to page 4. So, pictures of the tundra, it appears. Not the most welcoming looking biome. I mean, that one's cute, right? In the springtime, you got some flowers, but overall, just not the most welcoming environment. Tundra is generally a cold and treeless biome with low growing vegetation. So it's got some plants. It's not like it's totally plantless. It's got some. You can see it there, and you got some mosses and things like that there. Some shrubs and bushes and low growing plants. But it's not like it's going to be a place that's going to have a lot of tall trees or grasses or anything like that. It's pretty hardy and low-growing vegetation. There are two different tundras. There's one in the northern hemisphere and one in the southern. The Arctic tundra is in the northernmost regions of Russia, Canada, Scandinavia, and Alaska. And then the Antarctic tundra, obviously southern hemisphere, is on the edges of Antarctica and the nearby islands. Do you guys know which one has penguins and which one doesn't? Important things. So hopefully this is stuff that you guys have already gathered, because you guys did a lot of this sort of research with that chart that you did and the presentation that you guys made. But the climate for the tundra specifically is going to be cold, windy, and dry. Sounds miserable. Long winters, short summers. It has a very short growing season, and it also has permafrost. Again, this is probably one of those terms that you've been hearing all throughout your school experience. Permafrost is just that layer of soil that never thaws, ever. It's wild. You can see the precipitation versus temperature right here. You got your temperature in this green line, and then the precipitation down here in the blue. So you can see in August, it gets up a little bit, maybe about 5 degrees Celsius. So not exactly what we would call a very warm place. Kind of an unfriendly place to live. In the summer, you've got 24 hours of daylight. And then in the winter, you've got 24 hours of darkness. So I think I've actually seen some TikToks about this recently from people in northern Alaska who, it's summer right now, obviously. And so they were like, oh yeah, it's 1 a.m. And they're showing this video of them looking out over the land, and it's like sunlit. So it looks like it's the middle of the day, even though it's 1 a.m. So you've got that 24-hour day of sunlight and 24-hour day of darkness, depending on the season. But they also have pretty low light intensity. And you can see why that would happen, because you've got the Arctic Circle at the top, the equator obviously, and the sun right here. So in the summer, you're going to have that 24 hours of daylight, while in the winter, you're going to have that darkness. Wild. And it's all about, as are most things, it's all about the tilt of the Earth's axis that leads to how the sun's rays are spread out over wider or more narrow areas. We talked about the permafrost. It's permanently frozen subsoil. So sub meaning underneath. So it's not the top layer of soil, but it is a layer of soil down below the top layer that stays frozen constantly, 365 days a year. This prevents proper proper drainage. So as it rains, when it does rarely rain, that rain isn't going to be able to really penetrate the ground like it should because of the layer of ice and frozen dirt. And it also doesn't allow plant roots to penetrate. So plant roots aren't really able to get down deep into the soil. They might be able to, barely kind of attach at the top, which is why you're more likely to find like lower growing shrub type plants in this area, as opposed to taller trees that would need to root deeper and can't, because they can't get through the permafrost. So here's a pretty cool picture where you can see exactly what we're talking about. It's icy, muddy dirt, basically, right? So you can see there's some roots up here, it looks like. You can see some roots from some of the grasses. But any plant that would require roots that go down deeper than this first little layer isn't going to be able to live in this area. The sorts of vegetation that you're going to find in the tundra are going to be things like lichens, mosses, grasses, sedges, reeds, and dwarf trees sometimes. So dwarf trees just meaning trees whose roots don't go very deep. So this is lichen right here. I love it. I don't know why I like lichen so much, but lichen and moss, I like both of them very much. They're just short, stubby plants, and they're very pretty. And you can see you kind of got some grasses, a few little flowers here and there, some shrubs maybe, nothing too serious, nothing that's really going to require the roots to go too deep into the ground. Now, with that being said, there are some adaptations that certain plants have done, ways they've adapted that allow them to live in these less welcoming areas. So things like the growth being stunted, like you're not going to find really tall plants or trees there. So the growth is stunted, the roots are shallow, and they branch out further. So as opposed to going much deeper and being kind of this reverse teardrop shape, the roots are more shallow and they don't go as deep into the ground. They're a little bit more, a little bit more fine. So on one hand, it would be a lot easier to pull these fibrous roots out of the ground, but that's just about the only way they're going to be able to grow in that really shallow vegetation or shallow soil area because of that layer of permafrost that is a little bit lower. Most of them are also perennials, meaning that they live year round, and they are long day plants, meaning that they can survive in a full day of sunlight if they need to. You see the difference between annuals versus perennials. So with the tundra, the permafrost specifically is what's causing that lack of trees. Because you've got some plants at the top, maybe a meter of what they call the active layer up here, where it's soil that is actually able to be penetrated. It's a little bit looser, so you can kind of, roots can grow down in there, and then you got the permafrost. So it kind of makes it difficult, obviously, for a tree that would have deep layers or deep roots down into the soil layers from succeeding there. I'm going to pause for a brief second so that I can check an email. And we have returned. Okay. Make sure we're recording. So there is one very important biological process that allows these long day plants to do well in these pretty harsh environments like the tundra, and that's called photoperiodism. We know how I love my words. If you break it down, photo means light. We know a period is a segment of time. So photoperiodism is basically this adaptation that allows plants with light cycles that vary a good bit, that have a lot of variation in them, to survive well. So you can see, if you're looking at the long day plants on the left of each of these, which are the types that you can generally find in the tundra, they'll do fine even when it's dark from 6 p.m. to 6 a.m. They do fine either way. Nope, wrong thing. Some of the animals that you're going to find in the tundra, they are all fluffy and white and adorable. Things like, caribou aren't white, but things like the Arctic hare, Arctic fox, snowy owl, polar bears, and caribou. So Hedwig, if you're a Harry Potter kind of person, Hedwig is a snowy owl, obviously. But adorable. Love them. Polar bears. Adorable. Arctic hares. These little cold bunny rabbits who just look so cranky at the whole world. Amazing. Love them. And caribou. There are certain adaptations that you can find pretty commonly in animals in the tundra. So we noticed, like I just said, a lot of these, except for the caribou, all these are white, right? And they're in snow a lot of the year. So it's no coincidence that these animals have white fur and they're staying on snow all the time. If this guy was brown or a darker color, obviously he would stand out a lot more against that white snow, and this guy right here would be able to hop on over and have his lunch. So it's important. That camouflage. They also have fur that gets darker in summer to help them adapt to that sort of brownish green summer and springtime environment. And then some of the adaptations they've had to make to the cold are things like an insulating layer of fat, body extremities that are shorter, and they stay in tunnels within the snowbanks. So why do we think that it would be useful to have shorter extremities in this situation? If you had shorter arms and legs, then that's just less of your body that your system has to worry about keeping warm, right? So this guy right here can tuck those arms and legs. He can turn into a little loaf, and he can tuck those up underneath him because he has very short extremities, and it helps him to stay warm. So it's less body to keep warm, honestly. You can see the Arctic fox in his little burrow here, blending in very well. Honestly, if you walked past that from a distance, it would be kind of hard to tell that that little guy is in there, right? There's also something that we refer to as Allen's Law. And this is exactly what we were talking about, that animals that have adapted to cold climates have shorter limbs and body appendages than animals adapted to warm climates. So you can see the example that's being used in these hares or rabbits, that the Arctic hare over here has really short legs. It can kind of turn itself into a little loaf. And then where out west you might see, like, what do they call, like, jackrabbits, right? Like these really long-legged, long-armed bunnies that are like longer tail. You can see those appendages and limbs are longer. So the colder it is in their climate, the more likely they are to be like rotund and small to help them adjust. So that is Allen's rule. Like always, we'll get a little bit depressy here and say the things that humans have done to the tundra. It's a lot. So we've done a lot to disturb migration routes by building things like roads and pipelines. A lot of those pipelines are built because of the oil that can be found in these areas sometimes. So what'll happen is somebody will realize, oh, we've got a huge oil deposit. It's underneath the tundra. Nobody lives out there anyway. It doesn't matter. Let's just build a huge pipeline out there to harness this oil and keep it for our own use. And so as they do that, they have to create roads so that they can put down the pipelines. As they put down the pipelines to get to the oil, nothing is perfect, and some of that oil will leak out into the tundra itself in places that it shouldn't be. It causes a decrease in the animal population, both from hunting, fishing, and that pollution. And it also destroys nesting sites and spawning grounds. So if you're having to build a huge oil field out in the tundra, then that is obviously going to mess up places where animals would be nesting, would be reproducing, having their mating season, whatever it might be. So you can see an oil operation here, how much land that takes up. Pipelines like this one that are going to disturb the migration routes for some animals. And then obviously hunting out in these areas as well. Not to mention climate change. We are actively releasing greenhouse gases that are destroying the average climate, right? The average temperature of our Earth. So throughout the years, you can see we can go back as far as 1880, and the average temperature anomaly in degrees Fahrenheit was like negative 1.5 maybe to start out. And then as you go up and you get towards 2000, 2010, it's way up here in the fours. So we are not doing a great job of taking care of the temperature of the Earth as a whole, and that is really heavily affecting the tundras.